We're here today with Keith Nordyke. Keith, what do you do with Lansmont?
I'm an engineering design manager for the equipment group. I've been here for about 14 years, and I focus on modifying and producing new types of mechanical equipment for the company.
Cool. What are you going to show us today?
Well, we're going to talk about the variety of things, but a couple of products that we made. We'll focus on one for the U.S. Army. And the primary machine that we're going to show you is a horizontal impact system that we developed for the U.S. Army to simulate roadside bombs and explosions, similar to what they'd be seeing in Iraq.
Uh-huh. All right. Looks like you got a picture on the screener. Let me zoom in on that and go ahead and show us what you got.
Yeah, what we have is a video, and it's self-explanatory.
That's a waste of minutes. Whoa!
We'll let that play in the background, but as you can see, there's a improvised explosive device along the side of a column of Humvees. Some time ago, maybe 2 years ago now, Lansmont was contacted by the U.S. Army to produce a machine to simulate roadside explosions, just like you've seen here. They're using it to test seat restraints, the seat structure, and the straps, and everything to protect a soldier against roadside explosions, typically seen. So in the vertical direction, it would be the lifting and the throwing of a soldier in the vertical direction. We gave them the test bed so they can improve every aspect of protecting the soldier.
Make it more survivable.
More survivable. That's exactly right. If an explosion were to take place and to throw a vehicle horizontally, not vertically, this is the machine the concept of the machine that we built for them. Now,
and what does it do?
well, basically what you do is you take a seat and a soldier and you strap them to this top of this table.
Not a real soldier.
Not a real soldier, absolutely.
a crash test dummy.
A crash test dummy. And we give it a horizontal impulse, similar to be throwing a vehicle sideways.
So you bolt the seat down, you put the crash test dummy on the seat, and then you whack it really hard.
Exactly. That's exactly what you do. But the soldier had to be stationary prior to the impulse. It's much more difficult to make that parameter than just having a...
So you can't make the sled roll down some tracks and run into something.
Right.
It has to be kind of hanging out, and then all of a sudden it gets a big whack from the side.
Yeah, they did not want to bias their result with an initial velocity or an acceleration prior to the impulse. From a compressed gas, we release it. We get this mass up to a certain impact velocity, which is faster than 15 meters per second. And we control the duration and the amplitude of the pulse with these elastomers here. The charge, the impact mass, the impact point, and the travel. It's remarkable how violent the impact is. It's hard to have a good feel for a 30-mile impact, but we saw one of these in slow motion at a moderate impact, at about a 15-mile-an-hour impact. And the seat restraint looked like it was going to break the soldier's neck. It would throw a soldier into the 4th floor of a building. People can get appreciation for that. That's, throwing you up 40 feet is pretty high.